The James Webb Space Telescope has been doing its thing and uncovering all sorts of cosmic secrets one after another. And guess what? It stumbled upon something super mysterious. At first, it seems totally mind-blowing and beautiful, but once you start asking questions about it, the real mystery unfolds. In this video, we're diving into a seriously strange and mysterious phenomenon that the Webb managed to capture. Let's go. The Webb telescope has spotted a place in space 40 light-years away from Earth that scientists like to call the Hell Planet. I know, it sounds intense. Well, it's officially known as 55 Cancri. This fiery ball of mystery has been sending signals to us for more than 2 decades, and we've been scratching our heads trying to figure out why. Now, after numerous failed attempts, scientists have come up with a theory. They believe that this super-hot planet, with oceans of molten lava and a core made of diamonds, has volcanoes that occasionally burst open. These volcanic episodes spew out hot gas, creating a temporary atmosphere. But this atmosphere is like a shooting star. It's there for a moment and then, poof, it's gone. According to a study, this volatile atmosphere burns off, leaving the planet looking bald again. Anyway, they're saying this is the reason behind the mysterious signals. Now, it's ready to point its lens at 55 Cancri and see what's really going on. The telescope will analyze the planet's atmosphere, measuring pressure and temperature to check if it's as unstable as they suspect. You see, these signals are like a light show in the sky. When the planet passes in front of its star, it creates a tiny eclipse, and we get to see the light from Earth. Sometimes it's bright, and other times it disappears completely when the planet hides behind its star. It's been a cosmic mystery, and scientists have been dying to crack the code. The new theory suggests that the Hell planet's proximity to its star might be making it act like a celestial smoke machine. Huge volcanoes and thermal vents could be opening up, releasing hot, carbon-rich elements into the atmosphere. But the gas gets blown away, and the whole cycle starts again. So, to prove this theory, the JWST is going to do some serious planet watching. It's going to check the pressure and temperature of the atmosphere and help scientists figure out if it's as unstable as they think. Now, let's not get too carried away. This is just a theory and it needs some solid evidence. Webb is like our interstellar investigator, and it's going to take its time gathering data to either confirm or bust this hypothesis wide open. It's a waiting game, but the suspense is kind of thrilling, isn't it? But the thrill is not over yet. I find myself marveling at the incredible discoveries unveiled by the James Webb Space Telescope, particularly its recent capture of the star-forming wonderland known as Sagittarius C. This spectacle lies just around 300 light-years from the central supermassive black hole of our Milky Way, Sagittarius A*. In this captivating image, the spotlight falls on a bustling region within an infrared dark cloud, resembling a cosmic bonfire with protostars as its embers. These newborn stars are in the throes of mass accumulation, their radiant outflows glowing brightly in the infrared spectrum. At the heart of this stellar cluster stands a colossal protostar, eclipsing our sun's mass by more than 30 times. An astronomical giant with a presence known to astronomers even before this exquisite image. The density of the surrounding cloud is so immense that it conceals stars behind it, creating a deceptive sense of emptiness in one of the most densely populated cosmic neighborhoods. Scattered like celestial voids against the starry canvas are smaller infrared dark clouds, marking the birthplaces of future stars. What adds to the intrigue is the vibrant cyan hue highlighting extensive ionized hydrogen emissions detected by Webb's near-infrared camera on the cloud's periphery. It's as if the very edges of creation are ablaze with the vivid energy of nascent stars. The unexpected vastness of this emission raises eyebrows among researchers, hinting at the powerful influence of energetic photons from young, massive stars. Delving deeper into the mystery, scientists are captivated by needle-like structures within the ionized hydrogen, seemingly arranged without rhyme or reason. These enigmatic formations add an extra layer of complexity to the dynamics of this cosmic region, leaving astronomers eager to unlock their secrets through further investigation. Despite this stellar drama unfolding 25,000 light-years away, The Webb telescope's proximity to the galactic center enables a close-up view that borders on the intimate. The telescope's precision allows astronomers to discern individual stars, providing an unparalleled opportunity to study stellar formation. It's like peering into the cosmic cradle itself. This unique perspective also opens avenues for comparisons between the processes at the galactic core and those in other parts of our spiral galaxy, such as its sprawling spiral arms. One burning question under the scrutiny of astronomers is whether the central region of the Milky Way fosters the formation of massive stars more effectively than its outer reaches. It's akin to pondering whether the bustling heart of our galaxy is a celestial hotspot for the birth of these colossal luminaries compared to the more serene outskirts. Now look at this. It first appeared as a glowing blob from ground-based telescopes and then vanished completely in images from the Hubble Space Telescope. Now, the ghostly object has reappeared as a faint yet distinct galaxy in an image from the James Webb Space Telescope. Astronomers with the Cosmos-Webb collaboration have identified the object Aztec 71 as a dusty star-forming galaxy, or, in other words, a galaxy that's busy forming many new stars but is shrouded in a dusty veil that's hard to see through, from nearly 1 billion years after the Big Bang. These galaxies were once thought to be extremely rare in the early universe, but this discovery, plus more than a dozen additional candidates in the first half of Cosmos Webb data that have yet to be described in the scientific literature, suggests they might be 3 to 10 times as common as expected. Jed McKinney, a postdoctoral researcher at the University of Texas at Austin, said, "This thing is a real monster. Even though it looks like a little blob, it's actually forming hundreds of new stars every year. And the fact that even something that extreme is barely visible in the most sensitive imaging from our newest telescope is so exciting to me. It's potentially telling us there's a whole population of galaxies that have been hiding from us." If that conclusion is confirmed, it could mean the early universe was much dustier than previously thought. The team published its findings in the Astrophysical Journal, 4 images of the same part of the sky in different frequencies of light. The image on the far right shows a dark patch that represents a galaxy. The image on the far left shows no sign of this galaxy. The galaxy Aztec 71 is clearly visible in the reddest color filter of the NIRCam instrument on the James Webb Space Telescope, but not at all in the bluest filters. The Cosmos Webb project, the largest initial JWST research initiative, co-led by Caitlin Casey, an associate professor at UT, aims to map up to 1 million galaxies from a part of the sky the size of 3 full moons. The goal in part is to study the earliest structures of the universe. The team of more than 50 researchers was awarded 250 hours of observing time during the James Webb Space Telescope's first year and received a first batch of data in December 2022, with more coming in through February 2024. A dusty star-forming galaxy is hard to see in optical light because much of the light from its stars is absorbed by a veil of dust and then re-emitted at redder or longer wavelengths. Before JWST, astronomers sometimes referred to them as Hubble dark galaxies, in reference to the previously most sensitive space telescope. Until now, the only way we've been able to see galaxies in the early universe is from an optical perspective with Hubble, McKinney said. He also remarked, "That means our understanding of the history of galaxy evolution is biased because we're only seeing the unobscured, less dusty galaxies." This galaxy, Aztec 71, was first detected as an indistinct blob of dust emission by a camera on the James Clerk Maxwell telescope in Hawaii that sees in wavelengths between far infrared and microwave. The Cosmos Webb team next spotted the object in data collected by another team using the ALMA telescope in Chile, which has higher spatial resolution and can see in infrared. That allowed them to narrow down the location of the source. When they looked in the Webb data in the infrared at a wavelength of 4.44 microns, they found a faint galaxy in exactly the same place. In shorter wavelengths of light, below 2.7 microns, it was invisible. Now, the team is working to uncover more of these faint galaxies from the James Webb Space Telescope. McKinney said, "With Webb, we can study for the first time the optical and infrared properties of this heavily dust-obscured hidden population of galaxies, because it's so sensitive that not only can it stare back into the farthest reaches of the universe, but it can also pierce the thickest of dusty veils. The team estimates that the galaxy is being viewed at a redshift of about 6, which translates to about 900 million years after the Big Bang. Now, armed with the incredible James Webb Space Telescope, scientists recently stumbled upon 6 new galaxies. But these galaxies shouldn't exist, at least not according to our current understanding of the universe. The telescope detected these celestial anomalies just 300 million years after the Big Bang. So, what are these mysterious galaxies, and how did they manage to elude our cosmic grasp for so long? These newly discovered galaxies have been fittingly dubbed universe breakers by scientists, signaling a challenge to established cosmological theories. They emerge from the cosmic dawn, 500 to 700 million years after the Big Bang, defying our expectations of finding small, young, and blue galaxies. But how did the James Webb Space Telescope make these groundbreaking discoveries? Well, it all comes down to the telescope's unique capabilities. Its ability to peer into the infrared spectrum allows it to see through cosmic dust clouds that would otherwise obscure our vision. This means it can observe objects that emit faint infrared light, revealing celestial wonders that were previously hidden from our view. However, the universe breakers defy this expectation, revealing a cosmos where massive galaxies, akin to our own Milky Way, existed much earlier than anticipated. So, what are the implications of finding galaxies that should not exist? For one, it forces scientists to reevaluate their models of galaxy formation during the universe's infancy. The known mass in stars during this period, according to the universe breakers, is up to 100 times greater than previously thought. So, what other cosmic surprises await us? How many more anomalies lie hidden in the depths of space, defying our expectations and challenging the limits of our knowledge? The James Webb Space Telescope urging us to question, adapt, and expand our understanding of the universe. The seemingly insignificant reddish dots that adorn the canvas of space reveal astonishing tales of distant galaxies that defy our existing understanding. One of the celestial wonders that captivates our attention is GNZ 11, a galaxy that holds the record as the most distant ever observed. Can you fathom the fact that the light reaching us from GNZ 11 embarked on its journey when the universe was just a mere 330 million years old? Despite its early formation, GNZ 11 challenges our perceptions by presenting itself as surprisingly compact. Have galaxies been forming earlier than we previously believed, reshaping our understanding of their size and mass? Venturing further, we encounter GZ10, a galaxy situated a staggering 133 billion light-years away. This distant marvel outshines theoretical predictions by nearly 100 times, suggesting a frenzy of star formation beyond what we envisioned. How do these accelerated star formation rates in massive galaxies alter our perspective on the efficiency of star formation processes in the early universe? Moving closer to our cosmic neighborhood, we find GNZ 9, situated about 13 billion light-years from Earth. This galaxy showcases an abundance of heavy elements like oxygen, carbon, and nitrogen, essential ingredients for life as we know it. The presence of these elements hints at star formation and supernova explosions transpiring in the early universe. Not far from GNZ 9, we encounter GNZ 8, challenging our existing models with its remarkably structured disk. Disks, previously considered improbable in the turbulent early universe, now raise questions about when disk formation truly began. As we navigate the cosmic realms, GNZ 7 captures our attention with its exceptional richness in dust. This abundance of dust particles suggests the early stages of planetary system formation. Finally, GNZ 6 reveals a surprising redshift, hinting at a potential location in a region of the universe with a slightly slower expansion rate. These 6 galaxies, discovered by the James Webb Space Telescope, mark a profound leap in our understanding of the early universe. But what do these revelations mean for our existing cosmological models? The early formation of galaxies challenges our established views, suggesting that the cosmic symphony of galaxies might have commenced much earlier than we once thought. The structured disks observed in galaxies like GNZ8 shake the foundations of our galaxy evolution models. The heavy elements discovered in galaxies such as GNZ9 unravel a tale of rapid chemical evolution in the early universe. The forging of these elements through supernova explosions challenges our previous notions of when these cosmic fireworks first ignited. Now it's time for the mysterious phenomenon. A recent revelation by the James Webb Space Telescope has unveiled a cosmic anomaly, a record-breaking free-floating brown dwarf, along with two other celestial entities known as failed stars. This intriguing discovery occurred within the youthful confines of the IC 348 star cluster, a mere 1,000 light-years away from our home planet. As Webb turned its eye towards the heart of the IC 348 cluster, it captured a mesmerizing image adorned with pink and purple hues, showcasing the celestial dance of gaseous nebulae and the faint glow of numerous stars. Amidst this, the telescope identified three brown dwarfs, each with its unique characteristics, challenging our understanding of stellar birth and the fine line that separates planets from stars. The standout among these cosmic misfits is the record-breaking brown dwarf, an entity not tethered to any parent star and boasting a mass approximately 8 times that of Jupiter. To put it into perspective, this enigmatic celestial body challenges existing theories about the birth of such objects. This revelation holds the promise of aiding astronomers in refining the delineation between planets and stars, a question that has lingered in the pages of every astronomy textbook. Kevin Luhman, the lead author of the research and a scientist at Pennsylvania State University, expressed the core inquiry behind this astronomical pursuit. One basic question you'll find in every astronomy textbook is, what are the smallest stars? That's what we're trying to answer. The journey to these discoveries involved the focused gaze of Webb's near-infrared camera upon the wispy gas and dust of the IC 348 star cluster. Situated within the larger Perseus star-forming region, this young cluster provided a unique vantage point. The brown dwarfs within IC 348, still aglow with infrared light, revealed traces of the heat lingering from their formation. To delve deeper into the mysteries of these celestial outliers, the most promising candidates underwent an intensive follow-up investigation. The Webb's near-infrared spectrograph microshutter array played a crucial role, allowing astronomers to distinguish brown dwarfs from distant background galaxies. This meticulous process narrowed down 8 potential brown dwarfs to the 3 that now hold the spotlight. The designation failed stars for brown dwarfs stems from their origin, born from collapsing clouds of gas like their radiant counterparts, but never amassing enough mass to ignite the nuclear fusion of hydrogen to helium within their cores. This lack of fusion distinguishes them from conventional stars, and it raises questions about the smallest bodies capable of undergoing stellar birth. A perplexing aspect of brown dwarfs is their intermediate nature, straddling the boundary between stars and large planets. Their masses often rival that of Jupiter, the most massive planet in our solar system. Yet, the precise threshold for stellar birth remains elusive, complicated by the fact that brown dwarfs aren't complete failures in the fusion department. They exhibit the ability to fuse heavy hydrogen, known as deuterium, within their cores. The small brown dwarf within the IC 348 cluster poses a particular conundrum for existing star formation models. Its diminutive size challenges the traditional understanding of how a cloud of gas collapses to give rise to such a celestial body. According to Catarina Alves de Oliveira, the principal investigator of the research and a scientist at the European Space Agency, it's pretty easy for current models to make giant planets in a disk around a star, but in this cluster, it would be unlikely that this object formed in a disk, instead forming like a star. This leads to a fundamental question that resonates through the corridors of astronomical inquiry. How does the star formation process operate at such minuscule masses? The disparity between the expectations set by current models and the observed realities in the IC 348 cluster prompts a reevaluation of our understanding of the cosmic ballet that gives birth to celestial objects. In the pursuit of unraveling these cosmic mysteries, astronomers find themselves at the frontier of knowledge, exploring the nuances of star formation at scales that challenge the limits of current theoretical frameworks. The discovery of the record-breaking brown dwarf and its companions opens a new chapter in our cosmic understanding, urging us to reconsider the very essence of what it means for a celestial body to be a star or a planet. If you're as intrigued as I am and want to stay updated on the latest cosmic revelations, don't forget to hit that subscribe button and ring the notification bell. Share your thoughts in the comments below. I'd love to hear your theories on what we just uncovered together. Until next time, keep gazing at the stars.